Good day, everyone. Today, I will be discussing representing real-life situations using rational functions. And in this session, the following objectives are expected to learn by the learners. Number one, recall polynomial functions. Number two, define polynomial functions. And number three, represent real-life situations using rational functions. Okay. Now, to start with, let us first proceed with the concept of what is a polynomial function. Polynomial function P of degree n is a function that can be written in the form P of x is equal to a sub n x raised to n plus up to a sub 0, wherein a sub 0, a sub 1, up to a sub n are all real numbers such that a sub n or the leading coefficient of our leading term is not equal to 0, and the n as our exponent for the variable x should be a positive integer. And here are examples of polynomial functions. P of x is equal to 3x squared minus 5x plus 4. Looking in our example for f of x, our exponent 2 is a positive integer. And then for p of x is equal to x minus 1, our exponent here is positive 1. For the g of x is equal to negative 7x cubed plus 2x minus 3, our exponent here is positive 3. And as well as our a sub n is not equal to 0, even f of x and p of x. And for the last one, we have h of x, which is negative 8. These are all polynomials. And why do we have to recall this concept? Because we will be discussing concept about rational functions, wherein in a given rational functions, it is a fractional function where the numerator and denominator should be both polynomial. Okay? Now, in our previous discussion about functions, we represent or we translate the given situation into a function. And this time, we will be dealing with representing real-life situations using rational function concept. Okay, now I do have here scenario number 1. Suppose Barangay Uno received a budget of 50,000 to provide medical checkups for children in the barangay. The amount is to be allocated or to be allotted equally among all the children in the barangay. Now, fill up the table. How much will each child receive if there are 10 children, 20, 50, 100, and 500. I repeat, Barangay Uno received 50,000 pesos to provide medical checkups for children, and it should be equally divided or equally allotted to every child. Okay, now here is the table. Suppose you are being asked to determine the amount allocated to each child. Therefore, if there are 10 children, now each child are going to receive 5,000 pesos. Remember, we do have 50,000 as our budget allocation. And if we do have 20 children, therefore each child will receive 2,500 pesos. If we do have 50, therefore, each child are going to receive 1,000. And if we do have 100, therefore, each child are going to receive 500 pesos. And if we do have 500 children, therefore, each child are going to receive 100 pesos. Now, the question here is, how did we able to find the allocated amount to each child. Now, in this case, since our y represent for the allocated amount to each child, y will be written here as our output. And then the number of children will serve as our denominator. And since the Barangay Uno receives 50,000 pesos. Therefore, the 50,000 will be divided by the number of children, and whatever be the value, that will be the amount to be allocated to each child. Thus, in our scenario number 1, we do have y is equal to 50,000 divided by x. Next, what if there is a philanthropist or a benefactor that wants to donate an additional amount to the budget allocated to Barangay Uno? Remember, Barangay Uno received 50,000, and there is a benefactor or a philanthropist who wants to donate an additional amount to the budget allocated, wherein each each child are going to receive 250 pesos. Okay. Therefore, if we do have this table, what will be the amount to be allocated to each child? Now, since we do have 50,000 divided by n, and we came up with a concept, or our answer is 5,000 plus the additional, therefore we do have 5,250. Next, if we do have 20, therefore 50,000 divided by 20, we have 2,500 at 2,500 pesos plus 250. Therefore, we do have 2,750 pesos. If we do have 50 children, therefore, we do have 50,000 divided by 50, and we have 1,000 plus the 250. Therefore, each child are going to receive 1,250 pesos. Next, what if we do have 100? Therefore, we have 50,000 divided by 100 is equal to 500 pesos plus the 250. Therefore, each child are going to receive 750 pesos. And if we do have 500 children, therefore, 50,000 will be divided by 500 pesos plus the 250. Therefore, each child are going to receive 350 pesos. Now, the question here is, how did we able to find the amount allocated to each child? Therefore, in the previous formula that we have y is equal to 50,000 divided by x plus 250, since the philanthropist or the benefactor will donate 250 pesos for each child in the barangay. Okay, now, based on our scenario number 1 and scenario number 2, we do have y is equal to 50,000 over x. Then we also have 50,000 over x plus the 250. Now, these two representations of our situations 1 and 2 represents a rational function. The question here is, what is rational function? Rational function is a function of the form f of x. I repeat, rational function is a function of the form f of x, wherein it is a fractional function. Fractional function meaning to say we do have a numerator and we do have denominator. And the denominator and the numerator are all polynomial functions. And our denominator, which is g of x, is not a zero function, because if that will be the case, or if that will be if that will happen, then our function will provide an outcome which is equal to undefined. Okay, now in that concept about representing or the concept of rational functions, now these rational functions will now be utilized in our preceding discussion. Here, we will be using that rational function as a representation of the real life situation, as our competency is being asked for us to master. Okay, now given a certain situation wherein an object is to travel a distance of 25 kilometers, meaning there is an object that will travel 25 kilometers. The question here is express the velocity. Okay, the velocity as a function of travel time in seconds. Okay, we are asked to represent or to present a rational function about an object that travels a distance of 25 meters, but we are not looking for the distance, but rather we are asked to express the given velocity of the object in terms of time. Therefore, we do have v in terms of t, which is the time. V is the velocity, is equal to the distance traveled by an object all over t, which is time. Yan. Now, therefore, we do have v in terms of t is equal to 25 all over t, where v of t is the velocity as a function of travel time in seconds. Okay, next, scenario number 2 or example number 2. A fence is to enclose a rectangular vegetable farm with an area of 400 square meters. If x is the length of one side of this fence, find a function p of x representing the perimeter of the fencing material required. Okay, I repeat. Now, in the given example number 2, we are looking for a function representing the perimeter of the fencing material required relative to x, which serves as the length of one side of this fence. Now, in the given example number 2, we do have the following informations that we are going to utilize. Okay, now here is the illustration. Instead of using a vegetable farm, I will be using a garden. Okay, rectangular garden. Okay, now with same area, which is 400 square meters. Okay, now, a fence is to enclose a rectangular vegetable farm, but in this case, I will be using a rectangular garden. Yan, with an area of 400 square meters, meaning to say the area when we multiply the length and the width of this rectangular garden is equal to 400 square meters. And if x is the length of the one side, therefore, what will be the function p of x representing the perimeter of the fencing material required? Now, in this problem, there are two concepts that we are going to use. The first one is the area of the rectangular garden, or the area of the rectangle. And the second one is the perimeter, which is the sum of the sides of the given rectangle. Okay, next, here is our rectangular garden. Yan. And then let x be our length and let y be our width. Okay, therefore, we have to use first the area because in a given problem, the area is equal to 400 square meters. Therefore, I already present the solution for the given problem. Now, area is equal to x times y, which is the length times the width. And in the given problem, the area is equal to 400 square meters, which is equal to the product of the length and the width. Next, since we are looking for the perimeter in terms of the x, which is the length, therefore we will be finding for the value of y because the y will now be substituted if we are going to find for the perimeter. Okay. And then we have to divide both side by x. Okay. Therefore, y is equal to 400 all over x. Next. Now I repeat, this will be replaced or 400 all over x will be replaced to the value of our variable y in the perimeter. Okay, now perimeter, we do have 2 length plus 2 width or 2x plus 2y. Remember, our y here is equal to 400 all over x. Therefore, by replacement or by substitution, 2x plus 2 times we have 400 all over x. Next, 2 times 400 is equal to 800 all over x. And remember, 2x can be written as 2x over 1. And we do have now 2x all over 1 plus 800 all over x. And this is the similar expressions. And when you are going to find or simplify the given dissimilar expressions, therefore you have to get the LCD. And our LCD here is the product of 1 and x, which is x. Okay? Then we are going to make our LCD as our new denominator, meaning we do have x here and we also have x here. By x is equal to 1 times 800, we do have 800. Therefore, since our expressions now have similar denominator, then we can rewrite it as 2x squared plus 800 all over x. And this will be our perimeter. Therefore, in the given problem, what will be our function? Our function will be p of x is equal to 2x squared plus 800 all over x. Okay, now this will be our representation of the rational function for what? For the area of a rectangular garden, which is equal to 400 square meters, and our x represents the length or one of the lengths of the given rectangular garden. Okay, now remember, when we talk about rational function is a function in the form of fractional function. Fractional function wherein the numerator and denominator are polynomial functions, and our denominator is not zero function, is not zero function. And based on our illustrations, here are our example of rational functions. With that, goodbye and God bless everyone. Happy learning.